We are within our virtual casting yard and we are about to start casting the bridge shown here on the screen. The first segment to be produced in the casting yard will be the pier segment, which is a base segment in the jargon of ABES geoCon, the program that will guide us along the geometry control of the casting process. Clicking on Next again brings up the screen with the setting out data for our base segment. Maybe the first point of interest here is the location of the secondary bulkhead. It's 5 meters away and in parallel with the primary bulkheads. No surprises here. Down here we have a table giving the locations of the 6 control points that we are planning, the planned locations. They are measured from the middle of the bulkhead, and there are 3 points 100 millimeters away and 3 more points 4.9 meters away. The x-axis is pointing away from the bulkhead into the segment. No surprises there. That's what we've actually planned in geodes. The lateral coordinates are already a little bit impractical because they still reflect the 2-meter offset of the cross-section origin and the cross-section that we've planned. Remember, the 2-meter offset is something we invented in geodes. So the middle control point, which we would probably like in the middle of the bulkhead, is at a 2-meter offset, and the same at the other side. That's impractical. And what's even more impractical is the fact that the vertical coordinate reflects the crossfall of this segment. That's difficult to cast, to say the least. A top surface that's slanting 2.5%. It would be much more practical if we could turn the segment in a way that the top surface is horizontal, and if we could shift it over so this B control point, which sits in the middle of the segment, aligns with the middle of the bulkhead. We can do that by using the inputs up here. Let's rotate the segment first, and we will rotate by using the control points. Control point A and control point C at the bulkhead define the horizontal direction, and we can immediately see a change in coordinates down here. The vertical coordinate for the first 3 control points is now at the same level. At the other joint there is a slight difference, but that's not a surprise because we know the crossfall changes ever so slightly away from the pier, from 2.5% to 1.1% 100 meters on. So this already reflects a slight change in crossfall. We are still not quite where we want to be. We still have this 2-meter shift to the side and the significant shift downwards. So next we define a translation and we shift control point B into the middle of our bulkhead, and immediately we can see the effects here in the coordinates of our planned control points. 4.5 meters on one side, 4.5 meters on the other side, and the 0 in the middle is what we would like to have, and lining up in the vertical direction with the top of the bulkhead. That's the other thing we wanted to achieve with this operation. Again, we have a 1/10 of a millimeter crossfall variation towards the other side, the secondary bulkhead, and that only reflects our planned shift or change in crossfall. Let's accept the data, and we have now set out the base segment in a way we can cast it. And if we go to File, Preview Cast Info, we get this sheet which we can hand out to our crew in the casting yard. It has all the information about the secondary bulkhead, and it also has the information about the planned locations for our control points. The surveyor can fill out these cells in the casting yard. When the casting is done, bring it back and we can feed the data back into the system. Once the segment is cast and surveyed, we can resume, and we click Next to come to this form where we now fill out the true locations of the control points as we have placed them physically into the concrete, and they may or may not be the same as we planned. It's not going to change the shape, it's just a different location of the control points. And we should also input the exact location of the secondary bulkhead in relation to the primary bulkhead. I'm cheating here. Rather than filling out all this data here, I'm clicking on Set Ideal, which means everything is 0, 0, everything is cast as we wanted it to be. At this point, we have an option switched on that we are not filling in the actual survey data, but we are filling in the deviations from the setting out data. This is an option that's set as a default. It can certainly be changed. There is applications for both. We accept the data, and we have just cast a perfect base segment in a perfect as planned shape. It's shown in green because that's as cast now, that's cast in concrete, and the adjacent two segments are shown in blue because these are the segments that can be set out next.